Hi, everyone. I'm Shiro, independent researcher in machine learning. Thank you for welcoming us for this exciting workshop. Today, I want to talk about the topic of how collective predictive coding ends up the future of science with AI. Um, as explained by the first speaker, the CPCMS interpreted science as a simple emergent system that performs collective predictive coding. This is a whole sketch of the CPCMS. That each agent observe the external objective world, and they form their own internal scientific representation, and they externalize like paper submission, and the other agent decided to accept the proposition by the researchers. This is a whole system of the CPCMS. So, what perspective will CPCMS offer us for shaping the future of science? I want to talk about the two perspectives in that question. The first one is about the AI scientist. How AI scientists would influence on the future of the scientific system. And a second topic is the research automations. What perspective CPCMS can offer us about the research automation beyond just AI scientists? So let me move on to the first topic, the AI scientists and the future science. Oh, are you familiar with this paper? This paper, the name of the AI scientist, is published by the Sakana AI, a large AI startup based in Tokyo. And this paper proposed a system named the AI scientist that conducts every step from idea generation, experimentation, paper write-up to peer review, even peer review, in end-to-end manner. And the generated paper is like this. The system can automatically, of course, the people prepare some basic template code for them, but the system, based on that templates, the system can automatically generate such kind of quality papers. But this is just the beginning of a stage of AI scientist. This system is very simple and lots of room for improvements. So, and the next generation in coming years and the coming months, lots of AI scientist related papers and products and programs will search in the coming years. So this is the age of the AI scientists. So what perspective will CPCMS offer us on designing the future of science with the involvement of AI scientists? Again, as the first speaker explained to you, in CPCMS, the science is depicted as the monetary agent system with the communication. And in CPCMS, an AI scientist is just one of the agents but with distinct traits. So no like special treatment of the AI scientist. This is just one agent with special characters. Okay, so let me explain what that can imply for the future of science. This is the graphical sketch of a CPCMS. Each box represents each agent, and each agent has its own unique parameters. And that condition on that parameters, the agent form its own internal representation. And based on this parameter and the internal representation, the agents observe the external objective world. And it forms this internal scientific representation. And based on that internal representation, the agents propose new global scientific representation candidates, and the other agents decided to accept or reject that representation. And it's easy to imagine that the human and AI scientists will likely have the different biases because they have different body and different experiences. That biases are represented in this its unique parameters. And so that's the different, it is, they would likely have the different internal representation, and so have the different observations. This means that this is lead to the diverse global representation sampling, because these sampling belong from the different agents, the human agents and the AI agents, it is imagined to be drastically different. This sounds good for the objective scientific practice, because each other human agent and AI agent can see the different perspective of the single object. So this is good for social objectivity. This concept will be explained by the last speaker. But at the same time, there's also concern about the lack of shared common ground, because their internal representation can totally different. So, and this is prerequisite for the social objectivity. So this is the concern about the social scientific practices. And also, because their internal representation is different, the proposition from AI or human is highly likely to be rejected by the human or AI, because their internal representation will look different. And as explained by the first speaker, the judgment criteria is dependent on the internal representation. So this means that from the statistical perspective, that this means the poor convergence of the distribution updates, because each sampling will not contribute to the distribution update. So in wrap up, the entry of AI scientists in the scientific community brings diversity. But this has two implications. The first one is this is good, because this promotes an objective scientific inquiry, and it enables more extensive sampling and a much by far faster and a much diverse extensive sampling. But at the same time, it also implies the loss of common grounds among scientists, including human and AI. And it means that the worsened distribution convergence. So while the diversity introduced by AI scientists enhances objectivity, it also creates a trade-off by raising communication challenges between human and AI scientists. We can say this problem like the human and AI scientist alignment problem. So the whole implication from this analysis is that it is crucial to discuss the design of science that incorporates AI scientists. Okay, this is the first topic. Okay, what I want to emphasize here is we should not just analyze the influence of AI on the future science, but we should discuss what scientific systems should be to include the benefits of AI scientists and mitigate the bad effect of the AI scientists. So let me move on to the next topic, the towards automated science system. This is a sketch, very rough sketch. This is not accurate, but this is a very rough sketch of the research automation studies. There's a long history of research automation studies. The first study even dates back to the 1960s or 70s. The first attempt to automate a scientific process is using the traditional AI and robotics to automate a scientific process. And even in the mid 2000s, the full automation from the hypothesis generation to even physical experimentation is realized by these research groups. And again, the AI scientists. But studies related to research automation have mainly focused on the automating a researcher's process or aiming to realize AI science. But the science is, as you know, the collaborative social process, right? that science is not confined into the single agents like this. But as I repeatedly told you, CPCMS view is a mathematical model of entire scientific community. It's not single like scientist process. And so it provides a starting point for the automation of entire scientific community beyond realizing the AI scientists. Of course, CPCMS is not like perfect depiction of a scientific activity. This is just a model, and this is based on some hypotheses and premises. But I think it's important to provide the first preliminary attempt to depict the entire scientific activity, and with the language of the probabilistic statistics and probability, because the machine learning, the foundation of AI, is based on the probability and the statistics. So if we can model the scientific activity as probabilistic model, we can model this total system as AI models. So I think the CPCMS can provide a good starting point for the modeling total scientific activities. So let me wrap up my talk. First, I told about the CPCMS enables a discussion on the potential impact of AI scientists on science from a probabilistic perspective. I said the CPCM, I'm sorry. I said the CPCMS, and I support okay. And next, I told about it also laid the foundation of designing and implementing new forms of science, such as future automated science. And there, I acknowledge there is discussion on this topic in the past, but the unique point of the CPCMS is we can discuss these topics from the statistical perspective. In what sense that is good or bad, from the perspective of like statistical goodness. So I think this CPCMS can provide a unique starting point to discuss the scientific problem from this mathematical perspective. Thank you.